Okay, example 2. You'll notice this one slightly different than the first one because we have a quadratic trinomial here and a quadratic binomial here. Anytime we see quadratic anything, we're going to consider, can I factor this thing, and how in the world am I supposed to factor this thing? And what we have to do is recognize structures to establish techniques for factoring. So, when I'm looking at the first structure, it's a quadratic trinomial, x squared something x constant. That's the two numbers, so negative 6 and positive 1 would do the trick here. Opposite signs create the negative 6. Negative 6 plus 1 makes negative 5. Be careful with 6's and 5's. Because if it was plus 6, it would be negative 2 and negative 3 to make a negative 5. There's all kinds of ways to make 5s out of 6s and 6s out of 5s. So just be cautious that you get the right one. Correct product with the correct signs. Opposite signs create the negative. And since they're opposite signs, they subtract the middle sign. So this first fraction, 7 on top, factors to x minus 6 times x plus 1. This one here is a quadratic binomial. Now, binomial, I'm looking at two types of factoring possible. Number 1, greatest common factor. Number 2, difference of squares. Check greatest common factor first because that's the easiest possibility. This has an x, this has an x, so there's a common factor of x. So, minus 5 on top, and then I'm going to do x times x minus 6 on the bottom. Okay. This has an x, this has an x, you take an x out, divide each thing by x to get the leftovers. Taking out a greatest common factor. Again, what you should expect to happen every single time in these problems is one of the factors will match one of the factors. At least one of the factors will match one of the factors. Okay? Looking at this, unlike the last problem where this was already done, right? We just had to fix this one. They both have an x minus 6. This has an x plus 1 that this one's missing, so I need to put an x plus 1 on this one, which means I need to put an x plus 1 on top. And this has an x that this one's missing, so this one needs an x, so this one needs an x. I have to fix both fractions. Again, my goal is to get both denominators to have all the same pieces. Now they both have x minus 6, they both have x plus 1. This x wasn't there, so I had to put it on top and bottom. This x plus 1 wasn't there, so I had to put it on top and bottom. And just like the last problem, and again it happens a lot, there's a minus sign in front of the second fraction that's attached to the 5 that's on top of the fraction that's going to distribute through this parentheses. So that's going to get me, for the first fraction, 7x, right? 7 is one thing, x is one thing, you multiply them together, you get 7x. For the second fraction, negative 5 times x makes negative 5x. Negative 5 times positive 1 makes negative 5. Again, be careful, that should be a minus sign right there. It's quite often forgotten about. On the bottom we have x being multiplied by x minus 6 being multiplied by x plus 1. Doesn't matter about the order. I like to put individual things in front personally, like x, just x on the front. I like to do that better. But if I wrote it like this, it's still right. Okay, there's nothing wrong with that. And also, unlike the last problem, notice this time we do have some like terms on top, so we should combine those together. 7x minus 5x is 2x, so 2x minus 5 on top is the simplest the top can get. X times x minus 6 times x plus 1 on the bottom. Every time, get the top completely simplified, leave the bottom factored form. The factored form should represent the least common denominator of the two fractions.